Okay, so we're going to be practicing looking for calculation strategies using what you know about the way numbers and algebra work. We're going to be thinking like mathematicians again to look for mathematical structure, probably in those numbers or in the equations. We're going to notice, we're going to find a calculation strategy with a partner. The icons may help us remember who's what we're supposed to be doing at that moment. So this is kind of like, this is when we're going to listen to each other, share our strategies. And this is when we get to write things down at the very end, when we're reflecting what we've learned. And again, like we did in the first two times, we're trying to generalize. What can we use that we can reuse for some other problem? So, what do you think might be mathematically important about what I'm going to share? And given that you guys saw the whole thing so easily last time, I'm going to definitely truncate the amount of time that we get to look at it. Are we ready? 3, 2, 1. Yeah, not very long. Think about what you saw for a moment. What seems important to notice? All right, share something with your partner. What's one thing you noticed what we saw? It's harder.
Yeah, it looks like X plus X equals, I think, right?
All right. Let's draw together as a group and share some of those noticings. Who would like to share something they noticed? Tammy?
I saw the variable x. I saw 2 of them.
You saw 2 of them.
Yes.
Great.
There was a plus in there.
There's a plus in between. Great, so we're adding 2 quantities together.
It was an equation.
So we saw an equation. Something else?
On the right side of the equation, there are 2 numbers, one being subtracted by another number.
So 2 numbers subtracting, I don't know, on right-hand side. Do you mind if I use right-hand side? Okay, something else?
I think the numbers were each 3-digit numbers. I can't remember exactly.
I think I saw 2.
Very large.
Yeah, they were big, right? They weren't little ones. Okay, something else?
I think the numbers are 116 and 64.
Great.
They were subtracted.
Definitely subtracted. Do we notice anything else about this? So we may add some noticings. So when we get to look at the thing again and you think, oh, I noticed in your head, please, think about that and we'll use that later. We'll add to our list here. Okay, so we're going to be now trying to find the value of that x that we noticed in the equation. Try to find the value that works. And you're going to be trying to be prepared to explain why your strategy works. So that's kind of critical. And again, try to remember new things that you notice that aren't on this list. What else can we add? What other information do we have? Yeah, and if you come up with one strategy or one shortcut, try to improve it. Okay, take, let's say 15 seconds, 20 seconds, and think about it. Again, no pencil or paper. Okay, so turn to your partner and try to together come up with a strategy or shortcut for finding the value of x. Go ahead.
I thought about the 2 numbers in my head are relative to 100, and I realized that 16 is 100 more, and 84 is 16 less than 100, so both of them are 16, so I realized x plus x has to be 16 plus 16. And first I thought about it as 32, and then I realized 32 splits nicely into 16 plus 16.
math, but I know that between 160 and 84,
Since you just guys are calculating, that's
so since it's twice, it's adding to, I know that's going to be.
That's the answer over here.
How did you think about it to get the 32?
I was doing the math in my head because I know that when you take 4 from 6, you get 2, and I take 8 from 7, you get 3.
So you just sort of did the opposite.
Yeah, and then I realized that part is 32. So if since I have twice of x, when I divide the 32 by 600, I think I like it.
Yeah, I didn't even
Well,
change
I always
116
find that
or
helpful,
84.
like,
I just did the subtraction in my
what's the
head.
word? Not just friendly numbers, but like landmark numbers like 100 or 50. It makes the calculation easier so I can go up from it and I can go down from it. Because to me, I had trouble figuring out the 84 from 116 because they're horizontal. It's like
Do you mind
my
sharing?
brain didn't really line it
Yeah, I
up.
think you got to share last time. You were sharing the strategy.
I like jumping on it. And then I feel like I saw the 2 jumps and I went, wait, those are the 2 X's. That's the same.
All right. Okay, folks, we've got some strategies we're going to share and study and look for relationships between. Yeah. I'm going to muddle it, and I apologize. Dawan? 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 Okay. Will you share your strategy first, please?
Sure. So Tammy and I knew that we can simplify both sides of the equation.
Okay.
So we saw x plus x on the left side, so we simplified it to 2x equal to, we just did a subtraction in our head, 160 minus 84, which gave us 32. And 2 x's were equal to 32, so that means 1x should be half of 32, which gave us x is equal to 16.
Okay. Can someone restate that strategy? I'm going to try to see if, when we're restating, if we can somehow connect this strategy to a number line. David, go ahead.
Alright, so they notice that both the left side has 2 x's, so they simplify or combine like terms, and that gives them 2x. And they also combine like terms on the right side by simplifying it, and also give them 32.
Okay. Can I ask you a question?
Yeah.
This is going to be a bit of a trick here. Imagine I put 116 here, and I put 84 here. Where would you put the 2 x's and the 32 in this diagram?
Alright, so I will put a 2x in between the 2.
So
Yeah.
like it's this?
Yes. And then x becomes that, because the idea is that it's the same distance between whatever you have there. The x should be the same distance to that.
Great. Okay, and then what do they do to get the value of x?
And since they knew that it's 2x and it's multiplying, the inverse operation of multiplication is division. So they divided both sides by 2, and that gave them 16.
Okay, I want to do the divide by 2. I want to do it on the ground. So divide by 2, and then x, and we have the 16. And I need to put some equal signs in just a second. Okay, maybe minus the number line that I definitely added. Does the rest of it feel like it represents your thinking? Does everybody see how this number line connects to that? Okay, great. Number lines can be very helpful for us if we look at the other strategies, particularly kicks. There was a second strategy that I heard of. I think Donnie gets to share his strategy. Sorry, while Donnie's describing his strategy, will we all think about how does Donnie's strategy connect to this number line that I introduced? Go ahead.
So when doing the subtraction in my head, I try to think of like not subtracting the numbers from each other, but how far away they are from an easier number. So 16 and 84 are both 16 away from 100. And then you have 2 x's, and they're both 16 away, so x equals 16.
All right. Can someone restate Donnie's strategy? Somebody nodded his table. Maxine, go ahead.
So Donnie noticed that code 116 and 84 are 16 away from 100.
So here's our 100. 116 is here. Yeah,
And
So- go ahead. Both 16 away?
yeah.
So, does it matter which direction I draw the arrows? I'm just curious. I want to draw some arrows. Does it matter?
No. Yes, I think,
So you're saying if I could do this?
yes.
Oh, shoot. Too late. Would have been great if it had them underneath. Oh well, sorry. Sorry, keep
And
going.
He noticed there are two X's, so that means one of the X's had to be 16.
Yeah, because the X's represent this distance, don't they? So good thing we had a number line to think about, right? Because it really represents it. Is this kind of what you were thinking? Super. Kit, would you mind sharing your strategy?
The strategy was very similar to Donnie's.
Okay.
I thought about it on the number line also in relation to the 100, but I also recognized that, like, I thought about it as the plus 16 and the minus 16, and then realized that was 32,
Mm-hmm.
and then realized that the two X's were half of that, and so I split the 32 into half,
Got it.
and sort of matched it up the same way that Donnie did on his
Got it. So you have the same final picture, but there's a middle step that's a little different.
Yeah.
Can someone restate the kit strategy? Becky, go ahead.
Notice that 116 and 84 were also 16 away from 100.
Yeah, so just a second here. Wait. I'm going to try it slightly differently this time. $16 away. Yeah?
I think he added the 16.
Yeah, so he gets 32, right?
Yeah.
So
And I think,
this,
and I
just a
think that
second.
32.
I want to record where the 32 came from. Okay, sorry, go ahead.
And then he noticed that there were two X's.
So we kind of did what this group did, didn't he? Grouped these guys. Okay?
And with that, he divided the 32 into half and got each X equals 16.
So we saw this whole distance is 2x, and it's 32. Oh, that's, by the way, okay, more practice needed. 2x's, half is each 32, so I think that's good. I wanted to record this 1/2 somewhere. How do I record the 1/2? What do you think? I guess brown. Equals one of these 16s.
I think I would record it slightly differently,
Sure,
because the
tell me.
32 on the number line kind of goes over the two 16s.
So you want to put this 32
Yeah,
here.
right? And then, to me, I kind of sort of split the top and the bottom number lines in half in my mind. And that's where the X, yeah.
So that's
That's
where
what
the
I saw
halving
as
comes
16,
from, right
yeah.
here. We're making that split visually. Okay, so now we're going to reflect on what we've got. Sorry, does anyone see any connections between these different strategies? Take a look at a moment and think about that. What are some connections you see between these strategies? Okay, so we're going to reflect on paying attention to blank and equations is helpful because blank, or you can write a response to the second one instead if you prefer. Using blank in an equation helps because blank. Okay, so find your reflection space, take a minute or so and write down a meta reflection prompt, and then we'll record some of them up here. yet.
I got one.
You got one.
Once I ask you, what are you doing the 600?
Yeah, let's talk about that later. Stay in character. Okay, when you're ready, please feel free to share what you've written with your partner. And in a couple moments, we're going to take a quick break. It looks like a couple people had to run out to use the bathroom, so this is a good moment for run away for a second. Okay, share what you've got.
This is the last reflection. I said, using a number line equation helps me because it helps me see what quantities can be equal to.
Find connections between numbers to simplify the numbers. Paying attention to break down those numbers again and finding that pattern.
That's how you try using numbers.
And the equations helps me because it helps you sort of see additional step that you have to take in adding or
Because I can see the representation and how to equally
Go for it.
Let's draw attention up to the front of the room for a second. We're going to share some of these. So now I'm testing my memory again. Juan?
Yeah.
Yes. Will you share yours, please?
Yes, using a number line in solving an equation helps me because I can use the distance to represent the difference between two numbers.
Number line in solving helps me to use distance. I'm muddling this somehow.
I think I meant to say the difference between two numbers can be represented.
Oh, the distance as the difference. I can write this. The difference between two numbers. Right? And where do we do that in our examples here? Where do we use distance between two numbers?
And so we have the arrows, or the distance between like one.
Yeah, any of these arrows is representing a distance. I don't know if this matters, but there's a small difference between these two, right? The arrows and the, what's kind of, I mean, I don't know if it's critical for this one, but what does that mean? Like, what's the arrow versus just line mean? What do you think? Any ideas?
Well, I know you asked, does it matter which direction? Because direction implies positive or negative.
Got it. So, no direction, direction included. That's the difference, yeah. Okay. There was another, would you share your reflection?
Paying attention to symmetry in equations can help me solve an equation without combining like terms.
So it's not always going to work, but here we have some symmetry, right? Where are some examples where we use symmetry?
So in Dunley's strategy, I saw the going up 16 and the down 16 as symmetrical to the plus x and plus x.
Yeah, and I feel like this should be this way.
Yeah.
Yeah. So he went down 16 to 84, up 16 to 100. That's the same amount. therefore we've got symmetry. And he didn't say 2 x's. He knew that each one had to be, must have been using symmetry. And then of course, you actually had a line of symmetry in your diagram. Is there another sort of different reflection that somebody would like to share? I saw actually a lot of people talking about number lines in their reflections. That was something that came up a lot.
You want me to share mine?
Yeah, go ahead.
I said paying attention to variables, the operations and the numbers in the equation is very helpful because it makes it easier to find the unknown numbers by breaking down into chunks.
Yeah, so all 3 of these work together, right? Using a number line, helping us find symmetry, and actually really paying attention to what are the numbers in this equation. How can I use these numbers efficiently? Great. So therein ends the 3 enactments.